So today's talk is about this, like how, in our excitement to adopt generative AI, we shouldn't forget that it's still in public cloud. And we need to make sure we secure our boundaries because risks are more today than they were ever were. And now you have potential actors with power of generative AI. So basically, this is what we're going to talk about today. How we're going to secure our infrastructure and our solutions which are hosted in Azure, and how we can leverage our Azure, the tools it provides, the services it provides, how we can protect our generative AI solutions. So to start off with, little bit now, this particular user group presentations are not supposed to be marketing, so this is absolutely devoid of marketing. But this is just one page for who am I. My name is Nitin Nagar. I'm Vice President and CTO of Blueberry Hawaii Technology Solutions LLC. Sorry for the whole, it's a big name, but it was started out in Hawaii. I lived in Hawaii for 10 years. Fantastic place. And the lady you see over here in the middle, I I named the company after the blueberry cheesecake she made one time on my birthday. So that's the origin story. Now, apart from this, I'm a volunteer. I love volunteering, and I'm a sci-fi buff. I'm a history buff, especially Roman Empire, and a lifelong learner. I love learning, I love sharing, and this is why we are here. So today's agenda. So we're going to start off with covering what is AI cybersecurity. We have learned about AI and what is AI cybersecurity and what's the Azure role in AI, like enhancing security for AI's solutions, and what are the Azure security features, what tools we have, what best practices we have, and then I mean, like I didn't want it to make this presentation just about a PowerPoint. So we're gonna do some fun demos. Like first demo, we're gonna see how we can secure a, let's say in this example, a machine learning workspace, how we can control it, how we can secure it using Azure services. And the second demo is more interesting, in which we have a generative AI solution hosted in a container, and we're gonna see how we can access. It's like a Chat GPT type solution, and which you can actually which where you're actually using your documents stored in a storage account to run through the document, see how the performance is, and also most importantly, again focusing on security, how you want to secure it so that uh, other malicious actors are not connecting to it. And the third part is just securing the generative AI apps using Microsoft Azure, where we're going to look at some of the tools. I think one of the tools just became in a limited public preview on 5th of May. So I'm not sure if I can actually show you, but I'm going to talk about it. I do have access, but I don't think, I don't know if I can show you that. And then, of course, in the end, summary, right? Any questions so far? Right? 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 All right. AI cybersecurity. So basically, like what we have seen so far is it's kind of quite a revolution. I mean, like everybody's adopting AI, but the risk remains. So one of the examples I was just going through the news that how many of you heard about the Visa enumeration attack? So basically, Visa faced a situation where bots and other actors, they were basically trying to attack its system using the cards and everything. So they actually came out, they call it an enumeration attack, and they basically came out with a generative AI tool to address it so that they can identify the pattern, that whether this is a malicious action or not. So they're kind of trying to have They call it a Visa attack account score or something. So basically, like this is one example. And also, one of the things which fascinates me is how generative AI is being used nowadays. Not only now, this one technology is very interesting. Like not only you have to protect the generative AI solutions hosted within your enterprise, but also you have to protect them from generative AI solutions hosted outside. It's kind of a double-edged sword this time we are in, right? Very interesting. And so basically, and what we had to make sure that we understand the risk. Now, this particular talk is not focused on actually how a generative AI solution is designed and architected, but rather on the security aspect of it. Okay. So here is like you can see the Azure's role in AI security. So you can think of it as the sequence that you need to take. Like you start with the secure AI development lifecycle. You try to focus over there, like make sure you're having the threat modeling, secure core practices, continuous monitoring you have incorporated in the data security, where you have to make sure you have the data encryption, data governance, and especially the differential privacy, which is how you handle and protect sensitive information in the documents, in the data sets. And the third part is a model security. You have to make sure your model verification validations are there. You have to make sure you have adversarial robustness is there. You have model interpretability is there. So basically just to make sure how your model decisions are made. And the topic of this talk, secure deployment, how you secure the infrastructure where you deploy those models, and how you make sure the access controls are configured, and network security, how you secure others accessing these resources. And of course, the last one, second last, monitoring and incident response, Microsoft Sentinel, and Defender XDR now, like, with Copilot security. My God, I'm so excited about that. We should have a talk on just Copilot security as well. And like now you're talking about Chat GPT in security. So that's fun, especially if you don't want to learn KQL. But I mean, like fun stuff going on. And of course, the most important is compliance and governance. This is where your Defender for Cloud comes in. They have some really exciting updates around it, like how you're going to secure your models and generative AI solutions over there. And of course, your AI specific security tools. So Azure covers all the core areas, but this is all the different areas you need to keep in mind while designing a new generative AI solution, especially in our case, we're talking about Azure Open AI. Any questions so far? Azure, right? Azure. So this is one that you must have seen this particular landing zone reference architecture. This is the Azure Open AI. I know the screen is small, but you can see all the usual suspects over there, including your virtual network, your private endpoints, private links, you have DNS zones, you have Microsoft Sentinel, Log Analytics Workspace. Azure. Now, what we just talked about before, all these aspects are shown over here. Azure. And this is ideally Microsoft recommends that we keep in mind. Now, this is a beautiful thing. I mean, like during my consulting career, it's kind of tragic sometimes the clients don't usually take the guidance of such as landing zone more seriously. They're considering as an option. And whereas we have to make sure that this is actually a mandatory like configuration before you actually do anything in Azure. And this is critical. And basically like what we're going to show today is based on this reference landing zone architecture for OpenAI. It kind of gives you the best practices on what you should do and can do to make sure your deployment is secure, right? Azure. So, I mean, like this particular slide, it doesn't cover everything, but just the usual suspects I mentioned, like like Azure keywords, Azure application gateway, web application firewall. We're going to use it in a demo today. Azure private links, Azure private endpoints we are using, Azure policies for enforcing the organization security standards, and of course, managed identities we are using because we don't want to use service principals anymore. Remember those keys and keys getting expired. And of course, your Azure private DNS zones we are using in our demo. All right, demo time. So this is a one first demo, and what we are trying to show over here, as you can see, we have a Azure machine learning workspace, okay? And what we are trying to do is we are securing it to access from outside. As you can see, the data scientist, by default, Azure machine learning workspace, the public access point is open by default. So we have disabled it, right? So you cannot access it from outside through internet. And even when you have a username, you cannot come in. And basically, like the only way over here in this particular diagram, like architecture right now is through a bastion. So you are actually connecting it through a bastion, and within which we have a set of private endpoints, and so that we are able to secure the connection from all the different services. And as you can see, there's no outside access from either from the container registry or storage account or AI services or keyword. So the only way to access it through Bastion or yes.
Bastion, what is that?
So basically, like so Bastion is one service you can actually access, like let's say a jump box or a VM through a browser, rather than just archiving to it. But it's in a secure way you can do that. So basically, so this way we are trying to keep it more secure. Second option, which is not shown in this architecture, is you can have a point to site VPN. So this way you are able to securely connect to, in this case, we are attempting to connect to the Azure machine learning workspace. So we are trying to securely connect to it while making sure nobody else gets in, right? So for example, as you can see, I have an OpenAI demo, and I have so as you can see, all the required resources, like we have Bastion, container registries, we have keywords, we have long analytic workspaces. We are leveraging managed identities as well as private DNS zones and private endpoints to make sure we are not exposing any endpoints outside to the public network. And the only way to connect to this machine is through a Bastion. And we have a VM over here. And in order to connect to Bastion, all I have to do is enter my username and password. And once I am in Bastion, now keep in mind, what I have done is I'm logging in using a particular user here, in this case, a test user. So only this test user is able to access this machine learning workspace. And I'll show you with a different user, which is actually a global admin, and I'm unable to access that. Just the way the whole security has been configured in this case. So let me show you. So now within this particular Bastion, I'm logged in as a test user at PhD Federal. And here I'm an administrator, right? So it's a different one. And within the demo, I have the machine learning. There's only one machine learning. There you go. If I go in, what do you see? API.
You're loading workspace.
Yep, it won't allow me because I have configured it just for one particular user. Even if I am actually administrator, I'm a global admin on this one. So this is first demo how you can actually tie it down to such a level so that you are able to protect your um,
How many people would have access to the bastion? I mean, I'm assuming more than one person needs to get to the
right.
sites on there. So they would all have access to the bastion.
Right, but only verified people. So here you're controlling who gets to the bastion, who
And
gets.
who does the verification?
Of course, you're administrator. You need to have those access policies and governance put in place because you need to know that who is able to access it and at what level. So you need to do that. But this is we are just trying to showcase that how we can protect here with the example. Even admin cannot get in with this particular one. So because I have configured it in a way that only this test user can get access to it.
Yes, I'll jump in it. And so the Azure Bastion is internet facing, has to be, so that it can be leveraged in order to access what's inside the private network here. But access to that public endpoint is controlled by Entra. So those all identities are controlled by Entra, or previously known as Azure Active Directory. So they identities need to be in the Entra, and B, they need to be given permission to use that bastion and the VNet of the actually the NIC of the VM and the virtual machine itself in order to use that bastion. So it's locked down by identity in the case of the Azure Bastion in particular. And then everything else Nitin is showing is via network.
So this is in this example, we just saw that how we can lock down a simple Azure machine learning workspace from outside interference access. Any questions before we go to the next one? Yes.
Sorry. So how much does that differ from the landing zone reference model, so to speak?
Sure.
Yeah. This one differs mostly in the fact that this one does not have a hub and spoke. So it probably ought to have a hub and spoke, really, if we were to have it as a complete enterprise pattern. This would be a spoke, and there would be a connectivity hub or a different VNet. Who asked the question? You asked the question. So there would be a connectivity hub with the VPN gateway that Nitin was referencing, or your express route, or I mean, in this case, it's just Bastion. So the connectivity would be in the hub, and they'd have multiple spokes off of that with your various workloads. And what you see here would be the spoke. We would move the firewall out to the hub. That would be the full-blown enterprise pattern by just spreading it out. Basically, what you see here in two VNets instead of one.
Right. Also, one more part which is not there as per the landing zone is disaster recovery aspects of it. So those things are not there. But again, the focus was to showcase in a brief manner how you secure it. But the next demo, the architecture has hub and spoke in it. All right.
Can you make it slightly bigger? Because I'm sitting right here, so I can see.
Fortunately, this is the no. Yeah, this is the biggest I can get. So, in this particular demo here, what we are doing is what you see is we have a generative AI, like ChatGPT-like solution now hosted in a container, right? So it's a Java-based solution with a React UI, and hosted in a container. We have a application gateway protecting it, and then of course, like from public internet, you're coming in, and basically you hit the UI that goes to your uh, API as well as indexer, which calls in your cognitive services in OpenAI and gets the information for you. The data in this particular case is stored the documents are stored in the Azure storage account, and we have set up private endpoints protecting it. And then, of course, you have a hub so that any egress, like to internet or to basically let's say other services, you are going through a hub. So this is the model we have in place. And let me showcase. So there are only two ways. So you can access the generative AI solution using the IP address of application gateway. Okay. And if you have basically like also if you want to actually access the VM to actually run the code inside there or connect to a VM inside here, you can connect through Bastion. So yeah, I'm going to show two ways to do so.
This is on top of Active Directory.
Everything is on TriID. That's the new name. So let's do that. There you go. So if you're at home, or if you're in office, or if you have access to laptop, this is the URL. It's HTTPS 4.153.1.26. This is right now. Oh, it is? Oh, sorry. Okay, good. There you go. So you can actually access, this is actually right now hosted in my sandbox. It's running in my sandbox. And what was the question? And you can actually play with it. So for example, question, what happens in the performance review? So basically it has the indexer running in the back, and it goes through it, and the cognitive search gets you the data. And so, but anyway, so the whole idea is we have a generative AI solution hosted in Azure. And the key idea is like how we can actually protect this solution. So if you see in this architecture point of view, of course, you can play with it as we see, but everything else is hosted in containers over here. So going back to the trial,
Actually, none of those answers have anything to do with the questions. The questions are about the health plan, and the thing is giving back its wishes. But the jobs, they tell the project manager is responsible for.
right? Let's say, for example, let's ask, okay, what's comprehensive coverage, and let's see the pricing.
Gotcha.
the whole idea of this presentation is not about how to design this generative AI solution, rather securing it. So basically, once you have a generative AI, open AI solution running in Azure, what we do is what we have done in this particular case is going back to the architecture. Okay. So as you can see over here, we are protecting our uh, user interface, which is designed in React, and basically through the traffic comes in through the application gateway, and we have a load balancer in there as well. And here we have only way to get into like we have a VM in this particular example. We have to actually run. We have VM inside here where we can connect through Bastion. So basically, the only way to connect to this particular one from on-prem will be through Bastion, and that's how. There's no other way to access this particular solution. So as per the landing zone that we have seen, this kind of fulfills the requirement. Any questions?
Online. So you're asking if you can use virtual VDI. So yes, if you've got connectivity from your so Azure Virtual Desktop service, for example, to the application, for example, and so in this case, the app is all running on a service called Azure Container Apps. That's the one in the middle, and there's a few containers on that thing that's actually serving up the content that you saw. And the app is using, you see Azure Open AI, and this one, it's on the bottom of the screen. So it's calling that to do its stuff, right? But for AVD, the users who are using AVD, you'd provide connectivity from on the left there. There's a hub VNet. So you'd typically provide connectivity to what a bespoke VNet, where the workload is, via the hub. I mean, so in a typical enterprise pattern, if you had Azure Virtual Desktop, then that would be in a spoke of its own, another VNet connected to the same hub. So it would go from spoke to hub to spoke to provide that connectivity. Good question.
As you use an AI, you're like it's learning, right? Continuous learning. So how do you, or what security controls do you have in place that prevents you from providing corporate secret information into the AI versus, just general public information that the AI can provide for collaboration or whatever it needs?
So you said that the AI is continuously learning.
But what is the control specifically is the question.
Right.
Restricted and confidential information from being learned into the AI.
Understand. So it's not learning from your information. It is not. That's a common misnomer, right? Particularly the OpenAI model shown on the diagram here, the one at the bottom, it's pre-trained. It's been trained already. It's been done. It's been fed data already, and it's been canned, and it's been trained, and it is static. So when you feed it your own secure data, like in the way that you describe, which is actually the pattern here. In this particular pattern, there is a store. So this is the example that Nitin's showing here. It's using a storage account and a bunch of internal documents about the healthcare plan of Contoso are uploaded to that storage account. So that's the private secret data example, right? And then those documents are then cracked open and loaded into Azure AI Search, which is the ones across the bottom here. So again, remains private. AI doesn't see it at that point. The search engine indexes the contents of this private data. And then the application running on the Azure Container Apps calls OpenAI and sends it the results of queries on those documents that the search has done. It sends it the contents to OpenAI. OpenAI takes the results of that search, parses it, and figures stuff out. It reads what it's been given and responds with an answer, but that doesn't train it. It doesn't remember any of that. It doesn't take that information and store it or persist it. It is completely stateless. The private data stays on the storage account. It stays in the search service where it's been loaded into and cracked open, and the OpenAI service, what it's sent and what it doesn't keep any of it. So there are no, so the controls don't apply because the AI does not learn from anything that it's been sent.
The data is not going anywhere. It's just an instance.
Yeah.
And all that data source that it is using right now in this example is in a storage account.
So basically,
SQL database, you could basically file shares, but it's within your instance. It's not leaving anywhere. And this is what it's kind of showing you that there's only one way to come out. So
all the networking is private and locked down, right? Which it actually isn't by default. All of these services are internet facing by default. So you have to configure them to be locked down and private, as you see in this diagram. And by private, I mean only the whatever's inside this spoke VNet. That's the only thing that can see those services, which in this case is our custom application running on those container apps. Is the only thing that can actually make connections to those services by the private link network you see there.
if you don't even see what's the UI, the URL, or nothing, it's just a IP address of the application gateway.
So in this example, where is the trained model being stored? Is it within the Azure Open AI service?
Yes, that is where. So, and the model is, you have a few to pick from, right? Various like GPT 3.5 or GPT 4 or the new one that came out, GPT 4.40, for example. You pick the model that you want, deploy it in an instance of OpenAI, Azure OpenAI right there. And then because of the networking, only what is allowed by the networking can make calls to the AI and ask it questions and give it data and get responses.
I do have a follow-up question. Let's say there's like a case study where they try to train the model to deal with patient information, like heart rate or whatever. Would OpenAI, Azure OpenAI be HIPAA compliance by default, or is there any additional work because they want to make more out of that model?
I have to look up the HIPAA compliance question. I think the answer is yes, because it is stateless. It doesn't store anything, right? So when you were looking at patient data, you can send it patient data again from your storage account. So Azure storage account is HIPAA compliant. Put it in a database, HIPAA compliant. Lock it down on the network so it's private, so it's safe, it's secure, it's encrypted at rest, all of those good things. Your application reads some of that data that needs to do whatever processing on, sends it to the AI, which then interprets it, summarizes it, whatever you want it to do, and gives it the answer to the question that you ask it, and respond. But there's no state, there's no storage. And in particular, like the other gentleman asked, it's not being trained on that data. Not being trained.
In this example, we are using GPT 3.5, and basically, like again, going back to the first one of the earlier slide, I mentioned that when you actually design a solution, you make sure that, especially in the model design, how you handle the sensitive data, and one of the gentlemen had a question on the redaction of the data. I mean, like those things, you take care of it in the design itself. Yeah.
So basically, in a nutshell, you have to protect it at the storage level before you process it into the model, learning model. I think that's where a security control could be placed at, or at least
In
whether
this,
it be discretional or non-discretional controls there, right?
Yeah, it's all secured at the network, number one. Also, not is it shown here? Is it? Yeah, it uses. No, I don't think we can show intra ID. So all the access is not just locked down at the network; it's locked down to particular user identities stored in the Entra ID that owns all of this infrastructure. So it's identity based and network based.
also, I would like to emphasize we are using a lot of managed identities in this case. We are not using service principals. We are not using a particular user's username in Entra ID. No, we are using managed identities to really lock it down. And this is why, like, it is a little bit different from the link zone architecture overall, because which is more general. And here the services are, like as Adam mentioned, they are open by default to public. Here we have to make every effort to lock it down, identify it. And this is what this example architecture shows. Yes, sir.
Just wanted to clarify. So the search query happens based on the identity of the user, because they're using Bastion and all that. So they have their identity, and that's determining what gets returned from the database, which then gets fed into the Azure Open AI, which then basically creates a response and sends it back. So that's kind of what's happening there.
So here, okay, don't confuse with the Bastion over here, because here you are actually, any one of you go to that URL, you will be able to play with it. So it doesn't require a particular identity of your, it's like general, you can go access it, play with it, because it's not taking into account your identity. You are not able to get access, just get access to the UI. But if you want to actually access the Bastion there, you want to access the virtual machine to make any changes or any other commands for the solution, that time you need Entra ID. And then it all depends, like, how you're getting in. With Bastion, it doesn't matter where you are. But if I can even have a point to site or like, Express Route or other weekend ways to get into there. It's up to you. But again, for actually a regular user in this case, you don't need an ID. You can just directly play with it.
Okay. Well, I suppose in this case, yes. So I guess in a hypothetical situation, yes, would that described situation be possible where, like, again, a user who has an identity is registered in an organization looking at proprietary information, return information that only basically limit the responses from the search result to what information that they are only allowed to have, because there's different levels of the organization.
Definitely, I think we can work on.
Yeah, I can take it
Yeah.
if you want. So there's going to be a number of different places. The answer to your question is yes, right? You just need to decide whereabouts you want that identity fidelity to be placed. And all of these services support using Entra to lock them down. Like we talked about Bastion, just if you needed to access the VM. But that, in this example, that would only be for administrators looking to administer the infrastructure. A user, Lytton showed the front page of this website just now, which was anonymous. There was no Entra protecting it at all, not even an SSL certificate. It is protected in this case by an application gateway, which is an internet-facing networking appliance. So it does have a security layer. In this example, it doesn't have an identity protection layer for the application, but it could. We could add that. We would add that to the application to so when you go to that URL, it will redirect you to log in with your credentials on Entra, and it redirects you back, and then it knows who you are. And then those credentials could be used, to your point, to then filter the search results from AI search, so that only the results that particular identity is allowed to see would be returned for that user. And those results are the only things that will be accessed, sent to the AI with, hey, whatever the question we want to ask the AI that has those results, it would then respond accordingly. The only OpenAI is a stateless service, right? So that Entra identity doesn't apply to OpenAI because you either have access to use the model or you don't. So the fidelity of the data is done in this example by the search results and the front end. It is the infrastructure that would need permission to talk to OpenAI. And that also can and should be secured with Entra, with the managed identity that Nitin was referring. So managed identity is a user account that represents infrastructure. So in this case, container apps, infrastructure can have an identity that represents it, that lives with that infrastructure. It's created and managed in that infrastructure, which by default has no permissions. And the best practice pattern is to give the infrastructure's identity access to that OpenAI infrastructure resource, such that even if a human were to log in and get access to things, he or she using their own identity wouldn't be able to call that OpenAI service using their credentials. Right? We only want the infrastructure to be able to talk to that, and the infrastructure is going to be running the code that has a replication that has authenticated the users and retrieved the data that is secure for that data. So that's the whole pattern. So that's a longer answer to your question, but that's the fidelity that you'd want to see for both the application and then also the administration of the infrastructure.
Thank you for the longer answer. I appreciate it.
Add to that, what Adam just explained is authorization and authentication process in its documents.
Right. And also, like, if you want to take a notch up, like you want to see that who can access what documents. And let's say in this case, it's a storage account in Azure. And it could be very well could be a SharePoint site, or it could be like in a SQL database or somewhere. So you have to leverage the other tools to make sure the identity, just like as Adam said, OpenAI have no idea what access you should have. So you have to leverage the like existing tools, like Azure Copilot Studio is one that you can leverage to design solutions. But it all depends on what you're looking for, who are the end users, what kind of data they'll be consuming. So you have to choose the right tool and the right mechanism. In this case, it's a simple customer service kind of an application, HR or customer service, where a bunch of data which is not having any sensitive information that you can use to display to others. Now, there could be a different case as well, where you have sensitive information. Then you have to leverage the tools that Microsoft provides to actually make it a much more reasonable solution. Because last thing you want to have is data leak problems. And of course, if you're in healthcare, then it's a bigger problem in the hand. Any other questions? Yes, sir.
I got it.
No worries.
Azure security policies for SCPs. Is that like based upon some of these use cases? How mature is Azure Azure policy in applying? I don't see it in this architecture, so I wanted to see it. How mature is it in most of these use cases that we talk about, as far as putting guardrails around it?
Yeah, you can take it. Then I'll respond to it.
So Azure policy is fine-grained to individual resource types. And so you have the ability in Azure policy to control each of these resources and confine them to certain rules or governance that you might want. For example, you might insist that the OpenAI service we've got stood up here is configured with a private link. We might require that. And Azure policy can be used if deployed to the subscription before any of this infrastructure is deployed, because Azure policy, it can enforce both before and after. But generally, it is used to governance is easier if you simply prevent things from happening in the first place. So by applying those policies to each of these resources, one for every single one, and you see a lot of different times here, and controlling how you want them to appear, then it can be used to enforce this pattern. So in other words, if you wanted all these same resources and this exact same application, you wouldn't need to put any of this networking on. If you didn't want to, it would still work. You could just make it all internet facing. That would work. It's actually the default, not of course what we're recommending here today. And that's bad practice, et cetera, Azure policy can be used to actually deny a deployment from that happens. Does that answer your question?
Yeah, I was maybe a little more familiar in the scenario of the Open AI. Are the security policy Azure policies like really data maturity level question? Are they very mature in handling most of these use cases? Obviously, I know the guardrails around Azure, but mostly specifically in AI aspect, meaning like one of the use cases, like I don't want X data going into, this learning model, things like that. I just wanted to, understand it just on the eye level. Is it the maturity level there or something to be developed?
So Azure policy can control things that are defined in the infrastructure that you set up, like the networking, for example, permissions, things like that. Anything that is configured when the resource is deployed, including the models deployed within it. But the data going in and out, Azure policy doesn't have a mechanism for controlling the data that goes in and out on any Azure service. You need something different for that. So Azure Firewall, for example, is your egress protection. But the question you asked, preventing certain things from going into that OpenAI, don't have a mechanism for doing that. There is a content control service, which is an addition, a separate service that you can use to validate the data first, and that's something else. So there's a content control service you can use, and have that check for bad things, stuff you don't want. If things look good, then you can hand them to the OpenAI. So again, you would use other services for the data, but you can just use policy for infrastructure.
Thank you, sir. So as Adam said, like some of the things are foundational still, like for example, landing zone, that's foundational. And how you leverage Azure policy, that's foundational. And again, like no matter what we do, whether we are hosting a generative AI solution or a regular Azure solution, you should have, this comes under governance aspect of it. And to the gentleman's question, one of the answers, like what Microsoft has for OpenAI kind of a services, one of the tools that that actually came, there was an article on 5th of May about how and what are the tools Microsoft provides.
Yeah, Azure AI Content Safety is the name of the service that would protect the data. Is that what you're going to talk about?
Right. So this particular screenshot is from one of the articles came out on May 5th. And basically this, so Microsoft offers okay, once you have the solution up in cloud, hosted and everything, you have got covered your networking aspect and all those things are covered. And you're getting the data in Log Analytics workspace, you're monitoring it using Microsoft Sentinel. What else? What other tools are there to help you out? And one of the tools that we talk about in this one is Defender for Cloud, how it is going to affect, how it's going to manage, especially in this case, our OpenAI services, machine learning models. So basically, it talks about how you basically leverage threat protections for Gen AI applications, and we used our Microsoft Threat Intelligence. And again, this is being delivered through Defender for Cloud in this case, and we are responding to all those threats, such as direct prompt injections, unauthorized access, model hijacking, all those things. How do you know what's happening? One of the things that you must have seen in Defender for Cloud is once you have provisioned the resource, how secure this resource is and what kind of provisions you can do or actions you can take, sometimes automated, sometimes you can have an exemption. But again, there your Microsoft Azure policies come in picture as well. You wanna leverage or define a policy for it. But what Microsoft is offering is, in this particular example, is how we can leverage tools, built-in tools in Microsoft to respond and protect the Gen AI applications we have hosted in our. And again, everything goes to Sentinel, and then it creates the incidents, and you can associate with ServiceNow or any other incident response tool, management tools to manage those incidents. But it kind of gives you a whole life cycle you can have, including automated response to handle any threats, any issues detected while like during the course of hosting of the application. Now, the only thing is, I'm not sure, Adam, that if I can do a demo on that. You can have it, 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 you can have it.
Yep.
Okay. All right. You can have it, you can have it. If that is the case, let's do the demo. You can have it, you can have it. Sorry, guys, I'm still struggling with this whole presentation. You can have a region. Okay. Let's do this. You can have it, you can have it, you can have it to make sure everything is okay. You can have it, you can have it, you can have it, you can have it. You can have it. As you can see, I have few OpenAI resources. I have machine learning resources created. Okay. And here we go, Wonderful Cloud. You can have it, you can have it, you can have it, you can have it, you can have it. So you can see I have 3 Azure subscriptions. Actually, I have it applied to one. All of these are in one subscription. We have something called Cloud Security Explorer. You can have it, and you can have it in which you can have it Microsoft offers. You can have it, you can have it in ML. This is your OpenAI resources. Here in this case, I select all and I search. You can have it, you can have it, you can have it, you can have it, you can have it. You can see it brings up all the OpenAI associated resources, models, everything over here. You can have it, 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 you can have it. And if I go in just like your regular resources in Azure, it will help me guide. This is one example which is completely unsecure. This is just for example I've created, but as you can see, you can have it provide suggestions that cognitive services should use private link. You can have it, in this case, it's completely open. And if I click on here, you can have it, you can have it, me what action I can take to secure it. You can have it, right? So another example, you can have it, 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 you can have it. Azure AI resources should have key access disabled. Now this really helps, right? If you have, yes, sir.
Just to clarify, when you say OpenAI, are you saying Azure OpenAI or just OpenAI in general?
Azure OpenAI.
So will this work with OpenAI?
No. You can have it, you can have it, you can have it, you can have it. You can have it, you can have it, you can have it. You can have it, 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 you can have it. So here in this case, I'm showing one example which is not part of the demo. This is just one service I created, and just to showcase, like, you know, what kind of vulnerabilities the system would identify, right? And here, just like any other different type of cloud options, it not only provides you a quick fix, it also provides you, like, you know, how you're gonna delegate it or exempt it, or what kind of automation you can have. Is pretty, you can have it pretty helpful. I mean, like, if I am actually trying to leverage it, and for example, let's see some of the services we have. You can have it. You can have it. This is the guy. which is running our, this is our demo too. This is the chatbot that you saw, and you see only thing left is a no. It has identified. It can have it, 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 it can have it. So it is asking you should have the customer managed keys. I'm using the Microsoft managed keys interface. But still, it was able to identify. That was the only thing it could figure out. So this is one of the tools that you can use to make sure that how well you have secured your resources. And Microsoft does provide a tremendous job in actually like giving you the insights on how you can secure it. So I showed you one example, which is completely just a OpenAI app with all those issues. It was able to identify. Here in this case, it is only able to identify low level, which you can decide to, if you want. It can have actions. It can have it. It can have it. It can have it. It can have it.
How is the Microsoft Defender for Cloud license? I can't remember.
It can have it. It can have it.
Pay as you go, or
it can have it.
It varies by the resource that you're selecting, that you pick. It is all pay as you go. Yes, in the short. And you choose what resources you want it to protect. You know, these VMs, these storage accounts, and so on and so forth. Just pick whatever you want, or everything. I mean, you choose. It'll protect what you want, and then there's a pay as you go price per resource type per month for the service. Some resources don't cost anything. Some cost more. It varies by, like VMs cost one thing, storage another, and so on. Some by amount of data in them. I mean, it varies a little bit, but it's all pay as you go and depend on it.
You can have it.
And add to that, there's a cloud foundational protection that are free, for which what
it can have it. 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 It can have it.
capability unless you upgrade.
It can have it. 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 It can have it.
Will it be back right now? But it's one more.
It can have it.
I'm gonna make that just in case.
It can have it. 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 Essentially, as you can see, in the end, number one thing that we have seen that we have to safeguard our data. We are leveraging, we encourage to use encryption and access controls to protect sensitive data. In our case, we are leveraging private endpoints, we are leveraging managed identities, we are leveraging Entra ID, access controls. We are also taking help of the networking to make sure this data remains secure. And most important thing is protecting models. In this talk, we haven't talked much about like what are the mechanisms to protect model theft and adversarial attacks. That I think would be a good topic for a new talk. But actually, like the most important thing is like what you do to build resilient applications so that we are able to secure the content. And this is again old wine in a new bottle. Ever since cloud came out, ever since everybody is making transition to cloud, one thing we forget, it is called quotations public cloud for a good reasons. And you have to make sure you protect your information. And one single most action what we can do is follow through the landing zone architecture that Microsoft proposes as a foundation to build our solutions, and all the tools that Microsoft provides handy in making sure not only your policies are being applied, but also you monitor them and see how well they are holding up. And of course, where we go from here, that's the thing. Now, once you have a in cloud, you have to make sure it's protected. You have to make sure we have the right configuration in, especially the governance aspect that we were talking about, Azure policies and how you're provisioning those resources, who has what access to them. And again, protecting the data, sensitive data, how you handle it. Again, who should be able to see the data, so how you define the different type of applications, how you host them. It all varies depending on what goal you're trying to achieve. And these are some of the resources that I have used. These tiny URLs should give you the access to these are all demos on GitHub. So I didn't code them, I just deployed them. So, but you should be able to access these demos. You should be able to deploy it in your own environment and see how it is working. And the last one is the URL. It should be up and running at least for next couple of days before I take it down. It's expensive, so take it down. But that's about it. I mean, like, yes, Gen AI is fun, a lot of interesting stuff. But when you actually try to actually leverage it in enterprise, you have to be very careful what you do about it, who can get access to it. And they're all, like I said, it's a double-edged sword. There are other actors leveraging Gen AI to attack. So that's it. Now you have to protect your, not only a Gen AI solution, but also protect your organization from outside, just like how Visa discovered. And this is one of the most interesting times, I think. Like I was talking to one of my friend. My personal opinion, I think is almost equivalent to a personal computer revolution at the time of Steve Jobs, because the kind of changes that we are seeing almost on a daily basis is astounding. But again, security is number one. It has always been the case in case of cloud. So we have talked nothing different, just leveraging the existing tools. And also the third demo covered like what Microsoft is coming up with to protect your, to see that how well your design is, how well your configuration is holding up. And actually, this is fantastic support to make sure our data remains secure and we are able to leverage or reap the benefits of Gen AI. That's it. Thank you for your time, and let me know if there are any other questions. Yeah, no, it's general. You can decide to use Bastion. You don't need to use Bastion with Gen AI. This is just an option. Like I said, you can also have a point-to-site VPN.
Yeah, in this example, the Bastion is only used to access resources that are locked in the network. So in the case of the first demo, that was so that data scientists who would be end users of that Azure machine learning workspace, they would need to access the website of that service in order to do their machine learning stuff, right? Create their machine learning models and things like that. But because it's locked down in the way that Nitin was showing, the VNet was all private, then the only way those humans would be able to access the web front end of the Azure Machine Learning Workspace is from a VM inside that VNet. Now, or connectivity from something else that has access to that VNet. So, for example, from on-prem or AVD, like he suggested, right? So that was why we had it in the first example. And in the second example, we had an application that was internet facing, running on container instances. So there's no business humans that needed private access to that. They could all go in the front end for that one. It was internet facing, that application. So Bastion in the second example would only be useful for developers, for example, to update that app. Or if you wanted to system admins who need to configure the infrastructure that the app is running. Right, or for DevOps patterns, things like that, those kinds of things, you need to monitor as a human or do some admin on that stuff. That's why you need Bastion. But the second one,
Yeah, so actually the second one, the Bastion, is there because as per the architecture, it says 2 stages. After the first stage, it's so locked down, I cannot access it directly. So I myself had to go in using Bastion and then finish the rest of the steps in the Linux in the Ubuntu VM over there. So this is just like showing that, okay, you secure your network, then you yourself are able to get in. Then Bastion is your way to come in and actually complete the job. But
deploy the code. Yeah, if you follow the link on the second one, it walks you through doing all this. It deploys the infrastructure first, but not the code. In order to deploy the code, you have to use the Bastion, get on the VM, and deploy the code on that service from the Bastion VM. Yeah.
Let me show you if I can.
Actually, if you're going to go back to your portal, Nitin, there was a question about how much this costs. So can we look at the cost management service and see how much you were spending on that? Did somebody come off mute?
Actually, it's not bad. Yesterday it was like $530. In subscription one, it's like
Tony,
$130 so far. So you can think of like 48 hours, $131, which is not bad.
How much was it? How much?
Just $130.
$130. And when did you stand it up?
It's just a couple of days back.
A couple of days ago? Okay. All right.
That's okay. I tell you, I'll tell you a story. One time I accidentally stood up a Azure Analysis Services, sorry, SQL Analysis Services, Azure SQL Analysis Services. I was trying to show a client and then I forgot to turn it off or delete it. 2 days later, $1,500 bill. I was like, what the hell is that?
That's easy to do. Yeah, I've had a customer, they on Cosmos, they in 1 month racked up $70,000 by mistake. It was like, okay, it scales because they caned it, right? Because it scales as big as you want it to go. And they just, oh, let's see how big it can go. It goes really, really, really big. I was like, oh, that was a lot.
Yeah, cost alerts, making sure. I remember spending $100 on HD Insight in 1 hour. It was.
Yeah. AKS, it now supports 5,000 nodes. That 5,000 virtual machines. So if you have the ability, because by default to protect you won't actually be able to stand that many up. Because there are soft limits on a subscription basis, many you can stand up. But if you make a support request and say, yeah, I actually want 5,032 core, 64 core VM, I want that. They'll go, okay, and then you can stand up 5,000 of them. That'll be a few bucks. You can spend a few bucks, not that hard. But that doesn't sound
$130.
That's pretty small. Question?
So as far as when the Azure Open AI talks to the storage, is that one transfer, one transaction? Because if the cost, we're looking at cost here, and we're talking about this, it's reading data from the database, from the storage. I mean, is that each question or each prompt one, or is it multiple? How does that break down?
I think it's
tokens. Yeah. So the cost of the services, that each one has its own costs, right? So OpenAI doesn't, one clarification, OpenAI, it doesn't read your storage account. It doesn't go out and read it. It can actually go out and read the internet if you want it to. You can disable that, but it will go out if you want, but it won't go and read your storage account. But what you'll do is your code will read from your storage account, and there's a cost for storage for reading that. And then your code will then send the results of your storage account to the AI and ask it some questions, read this document, summarize this, or, the sentiment of this, or whatever it is you want it to do. And then you pay for that in the form of tokens. So there's a certain number of tokens that you get, and the tokens are the amount of data that you send it in a single transaction over a period of time. So you get a number of tokens per minute. and you can choose what those are. And when you exceed them, it throttles you and said, no, wait a second, just hang tight, let some time tick by, or you pay more and have more tokens. If that answers your question. That's OpenAI specifically. And storage has its storage costs for stuff sitting there, depending on the tier that it's in, and then a small read cost as well. Azure Container Apps has a cost in that example for running those apps in there. We also have OpenAI Search, another service that we were using, right? Read from the storage. So what happens is in the second example, Azure AI Search reads from the storage account. It sucks all the documents in, cracks them all open, breaks them all out, indexes them, and then stores them. And there's a cost for that. So the cost for AI search, and then your code gets the search results and then sends them to the AI. And that's what the questioning aspect of the demo was.
As you can see from the forecasting, if I don't do anything to my...
Sharing.
Oh,
This is...
oh, okay. I'm so sorry.
What's your question? Yeah. It's an art. You have to cost management. Cost management is your friend. It's the service he's going to show now. This is how you see what costs what. You can set alerts. You can limit it, control things, set budgets, do all kinds of things. This is how you manage all of these costs and control.
It's not that I don't do anything.
Under load for these AI applications.
That's controlled by the number of tokens that you have, right? So if you have it, so initially there's quotas on how many of these things you can stand up for one thing, and in certain regions. So you can't have in any region you want, you know, in certain regions, and then certain models within that of certain regions. So like GPT-4 or the new one, GPT-4o, it's only in 2 regions currently. So you can have OpenAI set up in a few different regions, but certain models that you want, very specific regions you need to pick from. And then you might have to request that, there's quotas, things like that. Once you've got one, then it's the amount of tokens that you purchase, and there's a limit to those. But if you're within those tokens, then it's near instantaneous. When you run out of tokens, you need to please hold, please wait until time passes, and then, because it's tokens per minute, if that answers your question.
So you have to plan. Everything has a cost in Azure. Storage,
not everything.
processing.
Not everything. Subscriptions don't have a cost. Source groups don't have a cost.
Azure policy is free.
Azure policy is free.
That's a good
Storage accounts actually don't cost anything if there's nothing in them.
Yes, I've used
Free. You can have up to 200 per storage account per subscription. Yes.
Right. And let me show.
Another question over there? Go ahead. OpenAI? Right. What is a vector database? So that's a good question. Okay. So vector databases exist as part of the pattern of asking questions of your data. And what a vector database is a particular type of index that calculates how proximate data is and gives it a numerical value. So there are some good canonical examples like donut and roll might be both types of food, but donut and hill, they're not very similar at all. They're different things, right? They're still words, but so the relation between the different food, that'd be closer, be given a certain number, and further away for donut and hill. So that is how data that in AI search can be used to group similar data. So the process is we have the storage account where your private documents are, your specific content that you care about, that's special and secret to you. In this example, it was like health reports in the demo, right? So or it was about the healthcare stuff. That That's on the storage account. The AI search will read it from the storage account and then index it. And to your point, you can optionally, and you should, also create vector indexes of that data. When it cracks open what's in there, reads it, creates a vector database of everything it finds, so that when your code, in this case, it runs on the container apps, reads, it's answering a question, it uses the vector database to get better results from AI search. Now, this is before it's been sent to the AI, right? This is all prior to OpenAI having, you're not even asking AI the question yet. What you're doing with the vector search is narrowing down tens of thousands of documents of your personal private data that you might have, because you can't send 10,000 documents to the AI. So you have to narrow down what you send it when you ask it questions. And the vector database is one of the very good ways of doing that, because of the proximity capability that it has when it's indexing your stuff. So your code asks the vector database, tell me, something about food or something like that. It will return content that is food related, donuts, but nothing about hills. Donuts and rolls, but not hills, right? Because of the vector search, which helps give that data more proximity. You then get a better search result. There's no AI applied yet, but you have a much tighter search result, much less to send to your OpenAI instance, which you then might have questions. What are the sugar content of this food, for example? Something like that. The AI can then look that up, have other questions of the search database, and the indexes, because of the way they work, will give better results. And so the AI is more efficient, and you spend less money on tokens. So you send it less stuff because you've used the indexes to get better results from your large swath of data than you would otherwise.
Vector database is part of Azure AI search. Search engine, optionally, as Adam was pointing out, can do vectorization for you and say, yeah, do it. It invokes the vector database behind the scenes for you. But it is that service which uses vector database underneath.
AI search. It used to be called cognitive search. It's now called AI search. But yeah, it's like a Bing or a Google search engine. You feed it benefit, reads it, searches it, and now can create the vector databases. But it doesn't have much in the way. It has form recognizers. You can do all sorts of things to hunt through data, and it'll do a good job of opening things and providing good search results. And the vector databases help provide very accurate, or narrow the scope of your answers, to then send to the AI. Because what you don't want to do, these 10,000 documents I mentioned, you can't send 10,000 documents to the AI and ask it questions, because there's limits. Well, it costs you a lot in tokens for one thing. But there's also limits on how much you can send it with one question. You can't send, summarize these 10,000 documents. There's a limit on the number of tokens, kilobytes of data that you can send it with one request. Can't do that. So you have to have these AI search limit the results first.
So I have something over here, like in the demo too. First part, we checked, like you go to a URL, anonymously you can have access to the Gen AI solution hosted in the container app, and then you're able to see it. Now here, what I'm trying to show is that the first part of when you actually deploy the landing zone and everything, then you're logged out. You are not able to go in. You have to actually deploy the solution. This is where we go in using Bastion. And actually, these steps which I'm just showing you in the history is like, this is where you actually run the rest of the code to actually deploy the solution. So basically, like in this particular demo 2 example, we are kind of really securing our infrastructure in a way so that there is no accidental leakage. All the regular Azure services, we are leveraging private endpoints to make sure that everything is secure. and not accessible from outside. This is the second part coming in. But again, I don't have to, I can just use the browser to actually log in into a machine using Bastion. But you don't need it, just like a Lego box. Legos you play, right? It could be even a other virtual machine if I can access to. So
Yeah, question? Go ahead.
So, we're talking about securing our environment. So as far as like if we do in the other slide, we're talking about prompt injection attacks. But does the WAF, so like it has the bots and the OWASP managed rules or whatever, is there something there for?
Nope. No, the WAF doesn't currently protect against that. You'll need to use the service in Defender that he's showing to defend against that, and also the content protection service that I was mentioning. Those two services will put the WAF will protect against more generic attacks against your website, but not the prompt injector stuff, because the WAF doesn't know whether or not you've got an AI behind there. It just knows you have a website. So common attacks against websites, it'll protect against that, but it doesn't know that there's AI behind that, so it can't help with that. You need other services to do that.
Yeah.
You need other stuff. The WAF is good. You should have the WAF. Definitely have the WAF, internet-facing website, web application file. We should have that. That's the application gateway. But then when you have AI as well in your application, that's when you need these other services here. So more than one. As you perhaps seen the pan here, it's multiple things. You need lots of things. Entra, the Defender for Cloud, network security. There's quite a few of them. There's quite a few.
Microsoft Sentinel to see how everything is holding up.
Yeah, that's a SIM, so that will watch all the data that's coming from the various security services. Yep.
And as per the landing zone architecture, we are monitoring, we are saving the logs. So everything comes together.
Private networking,
right.
Entra again, protecting all the infrastructure, everything, and then Azure policy to ensure that everything is configured the way it should be, not the way it could be. Like he was showing how OpenAI could be deployed with an open. You can have an internet-facing endpoint using just keys, which is basically a password. So anyone with a password with access on the internet who knows the name of your endpoint can then make calls against your AI and ask it questions. Now it's stateless, so it's not, it can't. There's no risk of your data in that, but it's going to cost you money because you're going to have someone else using your tokens, and so that would be why that would be bad, right? So it's going to warn you against, don't do that. That's easier. It's easier to have internet facing and using keys, and that's the default. But what you should be using is Entra, Private Link, and all these other things that are not enabled by default. First scenario, yep. Mm-hmm. The purpose of the Bastion service is simply something that does RDP or SSH to virtual machines. It does just those two things, and that's it. And it's in place of the default, actually, of having a public IP on those virtual machines. You can have a public IP on those virtual machines. You can just RDP or SSH straight to that thing. As long as you know the password, you're in. So don't do that, right? But that's also the default. So Bastion is what you can place in front of having that public IP, which means your VM can then have just an internal IP, cannot be accessed from the internet at all, but Azure Bastion does. It's one service, and it does support multiple connections at once to multiple virtual machines. So you can share it, right? And you can have, so if you've got a bunch of virtual machines that need to be managed, or business users, in that first case, you might have a bunch of data scientists, might have their own virtual machine each, might have one each, and they would all need access to it. You don't need a Bastion for each VM. You know, one Bastion, give everyone access that needs to that Bastion, and then give the access that they need to their own VM. You tell them how to connect to the VM, whatever it's called, give it a name, and then they can each get to their own VM and then access the machine learning service. or use Azure Virtual Desktop. That'd be another way of doing it.
So there are more than one ways. You
More
don't,
than one
you
way.
don't really need Bastion, but equivalent you have to put in place.
Yeah. You need something other than a public IP on the VM. Bastion being layer 4, isn't it layer 4? Layer 7 would be app gateway. So that's HTTP layer. The Bastion is RDP or SSH is what it's doing to your virtual machines, but the front end is all HTTP. So it's web only, secured by modern auth via Entra. So it's a secure connection to a public IP over HTTPS only, no SSH, no RDP. That happens from the Bastion service to the VM behind it. So it's a way of avoiding doing any of that. Just HTTPS.
It's all about reducing the attack surface, right? If you narrow it down, you can better protect it. You've got 3, 4, 5 attack vectors that you have to protect. It's more work. So best.
Key part is there should not be any public IPs.
Yep.
So how you actually connect? So the one way is like RDP. If you still want to use RDP, then you have to make sure you have the right configuration, Azure Firewall or any other firewall to have the right type of rules that would help you, or use Bastion so that you're not worried about any RDPs, but rather using HTTPS to do it. So that's much more easier, but Bastion, that's costly.
Oh yeah, absolutely. But there's 3 different tiers of it. So you have the really cheap tier, the developer tier, very, very cheap, only available in certain regions, all the way up to premium tier, I think, with more features and yeah, it costs more per hour. Yep. None of those are free. Yep. Any other questions? Okay, well, I think okay, one more. I was about to close it out, but one more. We got time. Go for it.
Yeah.
There's a pull. No.
Yeah, it's very limited.
No, you can't. There are some tools for visualizing Azure resources. I'm not sure I'd recommend any, really. Yeah, I know what you want. You want to see a good picture of, rather than a big old list of stuff, or a nice architecture.
That's a very old problem. I'm trying to find a solution.
Solution to that one. The best practice really is to start with the architecture and the picture and enforce how that's laid down, so that rather than you having to reverse engineer what is this junk, instead you've provided the governance to say, well, I know what this is because I've controlled what this can be. So it can only be one of those because I'm not allowing anything else. So in Nitin's example there was some infrastructure as code that was used to create that. And we'll put it in, and so in a governed environment, you would control who does that and what infrastructure as code was used to lay that down. You control it and you own it. Because you control it and because you own it, the answer to your question is the diagram that was drawn that represents that infrastructure as code, and then you don't need to work backwards from the Azure portal, because then you do see, just like Nitin showed, a whole bunch of stuff. Okay, great, but it was deployed from this infrastructure as code, which is drawn by this Visio that someone created to represent it for you at some point, and through that governance, that's the best practice of knowing what's in your Azure subscription, controlling. I see that. Yeah, I understand the problem. You're inheriting a bunch of stuff. That's the classic problem of, okay, governance. We want governance now, but we didn't have that in the past. So how do I clean this up, right? How do I know what I have? that what I'd suggest is there's a few ways, but what you really want to do is delete and recreate via patterns that you control. That's what you want. Maybe not in that order, maybe not that, but maybe deploy it the way it should be, right? Following these best practices that we're talking about with private link and governance, and the question about Azure policy to make sure that it's done the right way. And okay, this is how we should deploy it. And there's my architecture. Deploy one of those. And then whatever this thing was that I've inherited, I don't know what that was that somebody else put there years ago. Who knows? I don't know what that junk is. Yeah, migrate the code or whatever was on that thing, VMs or web apps or containers or whatever it was, but I don't care. Migrate that to the way it should be, the way you've controlled it, that's governed, that's monitored, that's secured, that's private link, et cetera, and then delete the old junk, and then you just gone, get rid of it. That is the best way to deal with inheriting a mess. You have to clean it up. That's the candid way. That's the only way. Clean it up. Do it properly.
Right. And also, like one thing, my personal experience, like you have to first of all make the diagrams that make sense to you, because sometimes you inherit diagrams and you're like, I don't know what it means. It doesn't represent it. So you have to make sure, if you are working with the existing inherited infrastructure resources, you try to draw it out so that it makes sense to you. And second thing, identify the owners. And basically, if nobody owns the resources, then you have to figure out whether they are production or test. And then in a stepwise fashion, as Adam said, just remove the public IPs or just the links so that nobody can access and see who complains. Sometimes you have to go through the stage-wise process just to make sure you securely, in a time-bound fashion, in a careful way, you try to secure the existing inherited infrastructure. But from the diagramming point of view, you have to make it the way you understand. Because whoever made it diagram, if you're lucky, if you're left with diagrams from the previous team, then you have access to at that point of time. But usually I hardly have diagrams. I'm the first one to make the diagrams. So.
Right. Because thank you, Nitin. Round of applause for Nitin. Thank you. He's chosen to come out and get up this to Len. One last ask from each of you. So Nitin did put the links to some of the content, but I also put them up here. This is part of sponsoring the food for those of you in person tonight. Please consider pointing your camera at the QR code. It'll present you with a form. You'll be able to download the content that Nitin just showed, those links he had up there. Optionally subscribe to a newsletter from the developers division of Microsoft, up to you. But that's how this group provided the food for us tonight. So I'd appreciate your help with that sponsorship by just clicking the link. That would help all of us. All right, that was all I had. And that's it for this month. Thanks everyone for coming out. Who learned something? Anyone learned something? Okay, that's good. It's a good thing. You learn there's a lot to do in order to secure stuff, right? No easy button. There isn't an easy button. There isn't an easy button. Next month, we actually have another security-related discussion regarding some of the secure services in Azure lined up. So I hope to see some of you that next month. Thanks all for coming out. Thank you.